See, the exercise is evaluate integral over 0 to 2 integration over y square to 4 e raised to y upon root x dx dy. So what is the situation here? First I have to integrate this quantity e raised to y upon root x with respect to x. So write the solution. Let us see whether we are able to integrate this quantity or not. So the solution, I am starting with integration over 0 to 2 integration over y square to 4 e raised to y upon root x dx dy, which is equal to, what I do, I always mention the limits first, that which are the limits of x, which are the limits of y square to 4 e raised to y upon root x, this is dx and this is dy. So here inner limit of x, so that is x is equal to y square, 2x is equal to 4, and outer limit of y, which are the constants, so y is equal to 0, 2y is equal to 2, right? So here first I have to integrate this integral with respect to x. Y is constant, so what we have to do, we integrate e raised to y upon root x with respect to x. So do you know what is the integration of e raised to, say, some constant upon root x dx? What is this integration? We don't know. What is the integration of e raised to 1 upon root x dx, right? That means we are not able to integrate this quantity with respect to x. Clear? But suppose if we integrate this quantity with respect to y, then integration y, I am assuming x as constant, so let me write root a dy. Then we know what is the integration of e raised to y upon root a, right? This integration we know, but we don't know this integration e raised to a upon root x. But here the situation is I have to integrate with respect to x only. But you know, here the integration with respect to x is not possible, but we can interchange dx dy with dy dx also, right? That is the Fubini's theorem, right? When we can interchange dx dy with dy dx. In general we cannot interchange, right? But whenever the function is continuous, then we can interchange the role of dx dy by dy dx. Let me interchange the role of dx dy by dy dx. So this is equal to double integration e raised to y upon root x dy dx. Okay, so we have already interchanged dx dy by dy dx and we are able to integrate. But what about the limits? Do you think that we can, when we are interchanging this dx dy, when we are interchanging this dx dy by this dy dx, we need to write this in terms of and this in terms of y? How to write? We have this limit. The question is, now here the limit is inner limit of y. Here the limit is inner limit of y. So I have write y is equal to, and here I have to write the x limit is constant. So here the important thing is how to write this limit of y and the constant limit of x, right? This is the new concept, and this concept is called interchanging the limit of integrals. That means if our integral is in this form dx dy, then we convert it into dy dx, or vice versa. If it is dy dx, then we will convert it into dx dy. Clear? So now let us try to understand with this example that how this concept is working. What is the integration we have given? Double integration x is equal to 0 to 2, sorry, y is equal to 0 to 2 and x is equal to y square to x is equal to 4. So first we write, so what is our step 1 here? Our step 1, is I find out the curves from the limit, right? So which curves we have given? The curve y is equal to 0, y is equal to 2, then so y is equal to 0, y is equal to 2, then x is equal to y square and x is equal to 4. So x is equal to y square, x is equal to 4, right? These are the curves we have given from the integral. I don't only write these 4 curves, right? I observe which curve is the at lower limit, which curve is at upper limit. So this is situation y is equal to 0, 2y is equal to 2 and x equal to y square to x equal to 4. This is very much important. So in step 1 we don't mention only these 4 curves, but we mention that see y equal to 0 to 2, so I am writing y equal to 0 to y equal to 2, x equal to y square to x equal to 4, so I am writing x equal to y square to x is equal to 4. In step 2, what I do? I draw the region, right? So let me write in step 2, finding the region R. So here is the region. Let me explain. The line y equal to 0, which is x-axis, so line y equal to 0, line y is equal to 2, so this is the line y is equal to 2. Next the curve x is equal to y square, so this is the curve x is equal to y square, and the line x is equal to 4. The line is x is equal to 4, and this intersection point is what? When x is equal to 4, what is the value of y? Value of y is 2. This intersection point is when x is equal to 4, y is equal to 0. So all the intersection points also we have. This is 0, 0, and this intersection point is when x is equal to 4, y is equal to -2. Now these are the curves we have drawn. At this stage still we don't know what is our region R. Once we don't know what is region R, we cannot write the limits, right? See, we had given the limit is this with respect to xy. What is my purpose? I want to write limit for y and x. So here the inner limit of x is equal to something. Here I want to write inner limit of y is equal to something, right? So from these 4 curves we find the region, and from the region we write this limit, right? So there is the buffer stage in between these two. Here we have the drawing of the region, that is here. So this is the outer limit, y equal to 0 to y equal to 2, and this is the inner limit. Now there is a trick to find the region. Which trick we are using? First, observe the outer limit, y equal to 0 to y equal to 2, right? So y equal to 0 to y equal to 2 fixes the infinite vertical strip. See, y equal to 0 to y equal to 2, this infinite strip we have. What does it mean? Y equal to 0 to y equal to 2 means my region is always inside this strip. The region will not be outside of this strip, right? So the one thing is clear, that this portion is gone, this upper portion is also gone. Only I have to find out my region inside this strip. Now observe here, x equal to y square to x equal to 4, and you know this is x equal to. So x, how do we write x? In this way, right? Here this is situation for x. So ultimately I have to work with the horizontal line. That is what we are discussing since last 3 videos, right? You have to walk horizontally in this strip from left side to right side. My region start from this curve x equal to y square and will end at this line. So when you are moving, you have to observe at what time you are entering to this curve x equal to y square, that is starting of our region, and when you are reaching to x equal to 4, that is the end of the region. So let us start walking horizontally. Yes, we are entering. See, we are entering from the curve x equal to y square. That means this portion of the curve x equal to y square is starting of my region, right? We are continuing our journey inside the region and we exit from this line x equal to 4. This is the line x equal to 4. So this is the end of the region, right? In this infinite strip which fixes this line. So this portion, horizontal line y equal to 0, vertical line x equal to 4, and this curve x equal to y square, this is my region R. Is this clear to everyone? Again I repeat, first I look at the constant limits, which is outer limit. I find out infinite horizontal strip, then I observe this, right? This is the left hand side part of my region, right hand side part of my region. This is the entry in the region, this is the exit of the region. So this is entry, this is exit, which fixes this particular portion, region R. Now once R is clear, you know how to write the limits, right? Okay, so let us go ahead into the exercise. And therefore double integration e raised to y upon root x, I have to write dy dx, and for dy dx I write here y is equal to, which is inner limit, and x is the outer limit. Now how you write the values of y? To write y, we draw vertical line. So let us draw the vertical line. Let us draw the vertical line. We are entering in the region from this line. Which line is this? Y equal to 0. So this is my entry, y equal to 0. We move inside the region to upward direction and we exit from this curve. See, this is the exit, right? And exit is which curve? X is equal to y square. So x equal to y square is the exit, right? So y equal to 0 to x equal to y square. I have to write the limits for y. So y is equal to 0 to, what is y? Y is actually plus or minus under root x, right? But we are in the first quadrant. In the first quadrant, x is positive, y is positive. So I choose the positive value, y is equal to root x. So y equal to 0 is the lower limit, y equal to root x is the upper limit. Now I have to write the constant limit for x. What I have to observe? How much portion of the x-axis is covered by the region? So this much portion, from this point to this point, this one, right? So this is x is equal to 0 and this point is x is equal to 4. So left hand side point becomes the lower limit, 0, and the right hand side point becomes the upper limit, x is equal to 4. Clear? So this is how do we interchange the integrals. This is called interchange of the integrals, dx dy to dy dx. You know how to integrate this quantity? So let us complete the exercise now. This is equal to, Now I hope this is not difficult for you. Integration x is equal to 0 to x is equal to 4. What we have to do? I have to integrate e raised to y upon root x with respect to y. So root x is a constant quantity, right? You know what is the integration of e raised to ax dx? This is equal to e raised to ax divided by the constant, right? So here I integrate this quantity with respect to y. So what is the constant here? 1 upon root x is the constant quantity. So divide by 1 upon root x. Clear? With the limit y is equal to 0 to y is equal to under root x dx. And this is equal to integration x is equal to 0 to x is equal to 4. This 1 upon root x, which becomes the numerator root x, and this is e raised to y upon root x. I substitute the upper limit y equal to root x. So what happened? This is e raised to root x upon root x minus sign for lower limit. Now I substitute y equal to 0. So when y equal to 0, this is e raised to 0 dx equal to integration x equal to 0 to x equal to 4 root x into, what is this? Root x upon root x cancel out. So this is e raised to 0 is 1. So this is minus 1 dx, right? Now you know e minus 1 is the constant. So let us take it outside. So e minus 1 is outside. What is root x? What is root x? Root x is x raised to 1 upon 2. So what is the integration of this? This is equal to x raised to 1 upon 2 plus 1 divided by 1 upon 2 plus 1. So this is equal to x raised to 3 by 2 divided by 3 by 2. And this is nothing but 2 upon 3. Right, so 2 upon 3 into x raised to 3 divided by 2. Therefore, what is the integration of root x? 2 upon 3 into x raised to 3 by 2 from the limit x is equal to 0 to x is equal to 4. And so this is e minus 1 into 2 upon 3 into, when x is equal to 4, this becomes 4 raised to 3 divided by 2. Now can you tell me what is 4 raised to 3 divided by 2? So 4 raised to 3 divided by 2, that is first square root of 4. Square root 4 of 4 is 2. 2 raised to 3 is 8. 8 into 2 is 16. 16 divided by 3, right? 16 divided by 3 e minus 1. This is the end of exercise. I repeat again. This is what we have given. First we try to solve with respect to x, but we failed to integrate with respect to x, right? We were not able to integrate this quantity with respect to x. So what we thought, can I interchange dx dy by dy dx, because I can integrate this quantity with respect to y, right? So I applied the concept of interchanging the limit of integrals. For that, first I collected all the curves, then mentioned the direction of the curves, that in which form they are arranged. I draw the curve. I started with the constant curves, right, and found that my region lies in this horizontal strip. Then I chosen the curve from the left side to right side and found the region R. Then in this region I write the limit of y and limit of x and then solve the integral. See, there are two new exercises. Evaluate integration 0 to infinity x to infinity e raised to minus y upon y dy dx and 0 to infinity x to infinity e raised to minus y square dy dx. What did you observe in both these exercises? Only the function is changing, e raised to minus y upon y, and here it is e raised to minus y square, right? The limits are same, 0 to infinity, x to infinity. So if you observe this thing, then y is equal to x, 2y is equal to infinity, x is equal to 0, 2x is equal to infinity. And the same thing is here, y is equal to x, 2y is equal to infinity, x is equal to 0, 2, x is equal to infinity, right? In both the integrals, what happened? E raised to minus y upon y, first I have to integrate with respect to y. The question is, can we integrate this quantity with respect to y? We don't know any mathematical formula which gives me the integration of e raised to minus y upon y, right? Then what is the integration of e raised to minus y square? That also I don't know, right? So the better way is, if I interchange the integrals dy dx to dx dy, then we can integrate this with respect to x, because when we integrate with respect to x, y is assumed as constant. So e raised to minus y upon y is constant, only I need to integrate with respect to x, and that is 1. Same situation will happen for e raised to minus y square. When I integrate with respect to x, e raised to minus y square is constant. So only I need to integrate 1, which is x. So this is the idea, right? Let us try this idea will work or not. Let's start with the first exercise, integration over 0 to infinity, integration over x to infinity, e raised to minus y upon y dy dx is equal to integration e raised to minus y upon y dx dy I want, right? So when I want dx dy, my inner limits for x and outer limit for y. And here what we have given? We have given y is equal to x, to y is equal to infinity, and x is equal to 0 to x is equal to infinity, right? As we discussed earlier, what is our first task? Our first task is to collect the curves, right? So in my step 1, I write the curves from lower limit to upper limit, lower limit to upper limit. So my constant curves, x equal to 0 to x equal to infinity, and then y equal to x to y equal to infinity, y equal to x to y equal to infinity. What I do? I draw these 4 curves first, then using these two and using these two, I choose my region. So let us draw these 4 curves. Here are the curves. See, the first curve x equal to 0, which is y-axis, x equal to 0. Now x equal to 0 to x equal to infinity. Question is, can we draw x equal to infinity? No, we cannot draw x equal to infinity. Y equal to x, so this is the curve y equal to x. Y equal to infinity, can we draw y equal to infinity? No, we cannot draw y equal to infinity. Now the question is, how to choose the region? We are able to draw only 2 curves out of 4. We are not able to draw x equal to infinity, y equal to infinity. So now what is our region R, right? So as discussed in the last example, look at this strip, x equal to 0 to x equal to infinity. What does it mean? We are starting from the line x equal to 0 and we move x equal to 0.1, x equal to 0.2, x equal to 1, x equal to 2, x equal to 3, x equal to 4, 5, 6. So we are collecting all these lines, x equal to 0 to x equal to 1, 2, 5, 10, 10 lakh, 15 lakh, 1 crore. All these lines we are collecting. That means my vertical strip becomes this, x equal to 0 to this part, right, which covers half plane of right hand side. Because see, this is x equal to 0, then I have to collect the line x equal to 1, I have to collect this line x equal to say 2, suppose this is the line x equal to 100, so I have to collect all these lines. I am collecting this part, whole this portion, which has the meaning x is equal to 0 to x is equal to infinity. That means my region is in this portion. My region is not in this portion, so this has gone. Only I have to find out my region into this part. Right, now in this part what is happening? Y equal to x to y equal to infinity. So I have to start from y equal to x and I have reached to infinity. Now what does it mean? Y equal to infinity means what? This line is y equal to 0. Say this is y equal to 0. Here y equal to 1. This line y equal to 2. This line say y equal to 100. Right. So y equal to constant is the horizontal lines. So actually the line y equal to 0 is this one. Y equal to 1 say is this line. Y equal to 100 is this line. Y equal to 1000 is this line. Right. So y equal to 0 to infinity upward. I have to start from y equal to x. Y equal to x is this line. This is the line y equal to x. So I have to start from y equal to x and move to the upside, because y equal to infinity is on the top side. Right. So let us start from y equal to x and move to upside. So when I start from y equal to x and move to upside, it fixes this thing, this portion. So what is my region? X equal to 0 to x equal to infinity fixes this part. In this part, start from y equal to x and move to up direction. Right. So which fixes this portion. And this. Is this clear? See how we have chosen this portion. X equal to 0 to infinity. This part we are starting from y equal to x and moving in upward. Right. So now in this region I have to write the limits. For which I have to write the limits? Here it is given dy dx. I have to write for dx dy. So how do you write the limits for dx dy? Inner limit of x. How do we write x? In this way. Right. So I have to draw the horizontal lines. So let us draw the horizontal lines. We are entering in the region from this. Which curve is this? This curve is x is equal to 0. So my entry is from x equal to 0 is my entry. We are moving towards inside the region, and we exit from this curve. Right, this curve. This is my exit. Which curve is this? Y equal to x. I have to write limit for x. X is equal to and x is equal to. So the lower limit is what? Lower limit is this point. Entry. X is equal to 0. What is my upper limit? Is this curve. This is y equal to x. So what is x? X is equal to y, which I write here. So x is equal to 0 to x is equal to y. Now this is constant limit. What I have to observe? How much portion of the y axis is covered by the region. So the lower point is this, y equal to 0. Clear? So my lower limit is obvious, y equal to 0. What about the upper limit? Can you tell me the value of y? Starting from 0, y equal to 1, 2, 3, 100, 1000, it goes to actually up to infinity. Right, because there is no bound. So I write the upper limit as y equal to infinity. So this is how we are writing the limit, x equal to 0 to x equal to y and y equal to 0 to y equal to infinity. Right. Now let us complete the exercise. So this we got from dy dx to dx dy. X is equal to 0 to y and y is equal to 0 to infinity. Now we integrate this quantity with respect to x. Right. Then e raised to minus y upon y is constant. So this is y equal to 0 to infinity. E raised to minus y upon y is the constant quantity. Remain quantity is 1, which has integration x. And then I substitute x is equal to 0 2x is equal to y and dy is remaining. So this is equal to integration y is equal to 0 to y is equal to infinity e raised to minus y upon y. Let us substitute the limit, upper limit x is equal to y, so this is y, minus x is equal to 0, so y minus 0 dy. What is y minus 0 is y, so y minus 0 and this y are cancelled out. So the remaining quantity is only integration y is equal to 0 to infinity e raised to minus y dy. Now what is the integration of e raised to minus y? This is equal to e raised to minus y upon minus 1 from y is equal to 0 to y is equal to infinity. So this is equal to minus sign, take it outside, y equal to infinity, so this is e raised to minus infinity minus e raised to 0. Right. Now what is e raised to minus infinity? E raised to minus infinity is 1 upon e raised to infinity. Exponential function is increasing function. 1 upon e raised to infinity is infinity and 1 upon infinity is 0. Right. So this is equal to minus of 0 minus e raised to 0 is 1. So this is equal to 1. Our second exercise was this. Here we had only e raised to minus y square in place of e raised to minus y upon y. So the same limit, same aspect will work, only we need to interchange e raised to minus y upon y by e raised to minus y square. Right. So this is integration y is 0 to infinity, e raised to minus y square remain constant. Now what is the integration with respect to x? Is x from x is equal to 0 to x is equal to y dy. Clear? When do we substitute the limit? This will be integration y is equal to 0 to infinity e raised to minus y square into, when x is equal to y, this is y, x is equal to 0, then the final quantity is y. So this integration is y equal to 0 to infinity y into e raised to minus y square dy. Now how do you integrate this quantity? If you assume that y square is equal to t, then what is 2y dy, or minus y square is equal to t, then minus 2y dy is equal to derivative of t. Right. So if I multiply by minus 2 and divide by minus 2, then this minus 2y dy becomes dt, integration e raised to minus y square becomes e raised to t, and this is minus 1 upon 2. Right. Then this is minus 1 upon 2, integration of e raised to t is e raised to t. Right. What is t? T is equal to minus y square. So the integration is e raised to minus y square from y is equal to 0 to y is equal to infinity. When you substitute the limit, y is equal to infinity, this is e raised to minus infinity, y is equal to 0, then this is e raised to 0, which is of the same kind, this kind of quantity, and so the final answer is 1 upon 2, as e raised to minus infinity is 0 and e raised to 0 is 1, so minus minus plus, so the final answer is 1 upon 2. whether in this exercise the answer was 1, here it is 1 upon 2.